Oops. All right. Hey, welcome everybody to today's webinar. We're really excited about today's topic. This is a really hot topic in AI, and visual predictive maintenance is being taken up in industries from coast to coast. And we're seeing a lot of interest and a lot of active adoption into live solutions in the field. My name is Jeff Toffoli. I am Clarify's product marketing manager. And today joining me is Praneet Sharma, who has a ton of experience in the field implementing these solutions for our customers. So I'm really excited to be able to offer this perspective. We're going to spend some time giving a bit of a high-level overview of visual predictive maintenance, what it is, how it works, what we're talking about. But we also want to keep a really kind of conversational tone to today's discussion. We encourage you to post questions in the chat, and also to just raise your hands if you see that there's a little hand icon, and we will unmute you, and we want to encourage people to sort of join the conversation and ask questions. And this format is here to help you along your AI journey, help you understand how these solutions might work in your own field, and give you a sense of what Clarify's already done and how this is helping customers achieve their goals.
Yeah, and I'll reiterate, so, keep it conversational. I was having a great conversation with someone who joined early. Definitely encourage that. Yeah, and definitely, ask questions in the chat window, raise your hand. Even feel free to interrupt, right? Like, we want to keep this, like, everyone inclusive. The last thing I think everyone hates is someone just blabbing on and everyone falling asleep, especially if it's lunch hour, especially on the East Coast, but we've got international people as well. So feel free to, chime in.
Yes, if you feel sleepy, feel free to jump in. Praneet, how are you feeling today?
Pretty good, yeah.
Today or what? I'm not feeling sleepy.
Yeah, so I'm out in the East Coast, so I'm in New York, but luckily, even during COVID times, I was able to go out in the field with interacting with fleet maintainers, interacting with people out in the field when it comes to maintaining just large, equipment, right? And I'm not just talking about like a vacuum cleaner, although you could actually potentially use this for vacuum cleaners. Like, we're talking about aircraft, we're talking about trains, we're talking about military equipment, right? We're talking about trucks, anything which can kind of suffer from damage because of repeated use. And really what we want to kind of expose here is, like, we want you to know your equipment, right? Like, we have these experts, right? Like, I've worked with engineers who just know a jet inside out, but they're not AI experts. So they have to translate this knowledge to me, and I have to actually say, okay, how am I going to build a model around this? Like, how am I going to build a model that detects corrosion? How am I going to build a model, that can detect fastener streaking? Or how am I going to detect a model that detects paint peeling or any type of rusting, within large equipment? So that's really what we want to kind of chime in here. So I think, I want to pose this question to you, Jeff. Coming in from a perspective, it's such a big theme at the company. What did you think of, like, okay, visual predictive maintenance, like what it was, right? Like, what was your first thought when you heard, okay, we're going into this, we're working with all these people? Like, what did you actually think it was?
Yeah. Well, so visual inspection, it makes sense that visual inspection would be part of a huge range of operations where you're working with within physical environments of all kinds. And especially if you're working on machinery, you'd think that you'd have your technical experts getting out amongst the machinery and just checking it out visually. I mean, this is our one of our most important human senses. And so visual predictive maintenance, well, this seems like I'm a bit more familiar with how this kind of technology works, of course. And so it makes a lot of sense to me, given that, that this would be a way to maybe automate that visual inspection process.
Exactly. So I think you really nailed it on the head, that it is a very sort of rich data process, right? And Here I'm showing kind of the Clarify platform. Like, how did I actually do all of this stuff, right? There's many AI platforms out there, but usually, when you think of AI platforms, there's a lot of silos, right? From data ingestion to annotation to data management to training to deployment. There's a lot of siloed processes that are kind of detached. And it was a great opportunity for me to actually go and talk to these field engineers, like, what would your process be of building an AI model, right? Like, translate this knowledge to me. And I was actually able to build it live while we were there, out of the depot, right? Like annotating bounding boxes and ingesting their data through an API from their database, organizing their data through our visual search. So we're getting rid of duplicates, we're getting rid of noisy data, right? Data management is really important, because if I feed, a downstream model very noisy data, then during testing and evaluation, I'm going to be very lost, right? And then being able to quickly and iteratively train. We were able to train these models that I'm going to show you in under an hour, right? And being able to retrain and constantly retrain, that is what's very important, because we don't have days to sit around, right? Like, that's a time cost. Like, and you're working with people who have little understanding of AI. They know their jet, they know their fleet, but they're probably going to get impatient and stop believing you when it takes, oh yeah, we'll get back to you in a week, we'll have to retrain, we'll get back to you next week, we'll have to retrain. So we had to do this very, very iteratively. So that's why, the Clarify platform that I was using, right, like, just as a practitioner, right, and helping these people, it allowed me to do that. It allowed me to cut that down to an hour. So that's a very important thing to address here. Is a lot of ML pipelines, they might be very featureful, they might have a lot of different connectivity parts and technical parts, but it's really about speed and iteration, right? Like, I just want to input data, annotate, organize, train, and I want to do that very, very quickly. So that's something I really want to stress here. And
so,
yeah, go ahead.
If I could just pause you there for people who are maybe less familiar with the ML pipeline and how all of that might work. It's probably easy to intuitively understand how a human would use their sight to inspect equipment. But when it comes to ML, we're interacting with computer systems. What does the customer put in and what do they get out? You talked about bounding boxes, training models.
Exactly. Yeah.
What goes in and what comes out there, and why do
they? So it's as easy as a side panel picture that is just a side panel, or it could be a video stream. It could be IR thermography. It could be the under panels. It could be a specific fastener. It could be a specific sort of like a panel connectivity. That's something they're taking imagery of. This is all very unstructured data, right? So that's what's coming in. What they're expecting is actually a chart graph at the end, right? All the way at the end of the risk behind the corrosion or risk behind the anomaly, right? But to get to that part, you have to have something that manages that unstructured data and annotates it and is deployable, not only in the cloud, but at the edge, right? In secure environments, right? They want their data secure, but also they want to do detection at the edge so they can actually manage it at the edge, right, where they are. So to do all of that in the middle, that's like actually the 99% problem. There's many things like, on the cloud, you could just like store your imagery in S3. That's fine. And there's many things that draw charts and graphs. There's many like open source tools that do that. But to actually annotate all that and do it with high confidence, that's the actual problem, right? That's what they wanted to build. Everything else they had and scaffolded and we could actually put together. And really, this is a good segue into this slide is how do you sell this, right? Like, how do you sell visual predictive maintenance to people that have the budget, that have the reins of actually how to deploy this? Well, you really have to convey the risk of not knowing your equipment, right? So equipment of all types can suffer corrosion. It's complex. It's made up of many parts. Human maintainers can make mistakes, right? Jeff, as you mentioned, right, this is a repeated process. Like a jet, you have to examine every day, every week, every month, but ideally they want to do it every day, right? But since it's so repetitive and cumbersome, like you're going to make mistakes. So the cost is very high. The equipment is essential. The time not being used is actually a compounding cost, right? Like if a critical jet, like a 737, is not being used for a route, it's just sitting there. There are many passengers over again that could be using it. Safety is crucial. So failure can be costly and disastrous. There's many times in the field where people describe to me, right, like this is actual fighter jet, where the canopy just flew open while someone's doing a U-turn, right? Like that's the scariest thing ever. And they had to do an emergency landing. Why did this happen? Corrosion. Corrosion basically made the canopy loose, and that was that. Like someone is just upside down without any protection. So safety is very crucial in these situations. And then considerable time and money is spent by human maintainers. I mean, it's repetitive, reactive. Like there is a shortage of these people, and there continues to be a shortage. Where can we add assistance and make their lives easier and make it better for everyone?
Yeah, and just to add on there, I mean, this is really where the excitement comes in. So I hope it's easy to understand how sending an expert out into the field to inspect your jets would be important for safety reasons, and for for just general maintenance and reducing the cost of maintenance. You want to see problems early, but when it comes to the ML version of this, you get to use a camera instead of human eyes. Cameras are tireless. You can send an
high resolution.
High resolution, send in individual images, or if you need time series, the easier way to think of that is you're sending in a video.
Yes.
So we're proposing a solution where you've got an inspector who never gets tired, and who can have this specialized knowledge that you otherwise would have needed to train people up over a long period of time to.
Exactly. Yeah. And also it's not just, you're replacing the inspector, you're actually organizing the data for them better. Right. So as I'll show you, like once it's all downstream, like the inspector just has to worry about the chart and the graph, or is it risky? They can also review that data. So this is where it gets into the T&E tools that we utilize is, hey, I want to see how the model's performing, right? Like I want to see the confidence level. I want to see how many false positives, what's the confusion matrix? Like I want to stitch models together. So I have like a detector and then maybe a classifier at the end to kind of reassess the actual corrosion. You can do all of this, but that requires, again, an end-to-end solution where that 99% problem is, okay, well, we need to solve all those problems very, very quickly. And, beyond just, I've been talking a lot about aircraft, right? It's complex, it goes through extreme environmental conditions, high speeds, high G forces, turbines, right? Like think of those wind turbines that, you see out in the US, right? Like in the West Coast, right? Like you see these massive wind turbines. You can see countless of them. This is proliferated throughout the world as an energy efficiency measure. They're very expensive and crucial to infrastructure, but just shipping that big turbine is a huge cost. And you can kind of see the examination process. Not only is it someone has to climb up and kind of view it and do that for potentially each windmill. If it's broken, imagine just like disassembling that, all the shipping costs, all the transportation costs, like the entire kind of cost of like a lost windmill, right? It's huge. And beyond just like individual stationary equipment, think of networks, think of pipelines, think of the vast infrastructure, think of Texas, what happened, right? Like this corroding infrastructure, and extreme weather conditions come around, and it's basically disabled. And you see this with pipelines, you see corrosion there, you see cracks, you see anomalies, and that's where, again, we want to address things beyond just like these stationary or vehicles, right? Like we want to address those. And that's where go ahead.
Let me pause you there. I want to kind of activate a little bit of audience participation. Can we go back to that previous slide just to
absolutely
kind of... Yeah. So if everybody looks in the bottom right hand corner of your screen, you've got a icon that looks like a speech bubble, and if you click on that, you can I would encourage everyone who has a specific use case in mind to just type it up here. For example, I've got a friend on the West Coast who's working in sewer systems, so I'm just going to give this as an example. And I do want to just get people talking here about what they're actually seeing out in the field and what might have gotten them interested in this topic to begin with. So there's an example. And yes, so feel free if you've got a specific use case in mind. So go ahead and throw that up there.
Yeah, and I can pause, so feel free if you think of one while I'm talking. I'll hear the chat thing, and then I'll be happy to answer it. I know someone mentioned computer chips. Again, we're exploring computer chips, like actually examining debris, contamination from very, very high resolution imagery for computer chips. That's again, it's crucial equipment. There's a shortage, so everything matters. And this is something that again is applicable. So you really have to get creative around. Okay, this is a piece of equipment. Can I inspect it visually? Or it doesn't really have to be traditional visual imagery. As I mentioned, IR thermography, right? Like if you can transpose into a visual domain, that's also applicable. We've trained models that analyze spectrograms even, right? Like audio data in a visual form, and they work really well.
Yeah, so any spectrum of light, very small objects, very large objects, we can create specialized eyes that can inspect various.
Yeah, absolutely. Yeah. So really quickly, I mean, why would you want to do this with AI? Jeff and I have been kind of hammering this. You get automation and precision, you create a shared data environment, and then you get to deploy models in multiple environments, right? Like you can take those eyes everywhere. Yeah, manufacturing lines, that's another one we're exploring with a partner actually, is quality control. We're not necessarily doing it with beverages. We're doing it with the pharmaceutical companies where they have like little bottles and they need to actually, right, it could be like something very critical. But again, yeah, manufacturing lines where people just aren't even there, right? Like there's no one just examining every bottle very, very precisely. We are doing that with just stationary, Navy ships, aircraft, vehicles. Navy ships particularly can suffer a lot of hidden corrosion. Submarines, right? Like very expensive equipment. A lot of use cases there. But it's all one theme, right? Is you want to reduce downtime, you want to reduce cost, right? And you ultimately really, really want to reduce risk. I think one of the talking about the story of like the canopy, just flying off. That's one. I mean, a lot of people here fly commercial, right? And there's a recent article that came out that really talked about the Airbus issues of just paint peeling. And I'm going to show you a model that has paint peeling on it. But did you know that the paint is very crucial to prevent against lightning strikes, right? Like, so next time you're on a jet, and not to freak everyone out here, like you really want to examine these things because these things are crucial. Many people fly on this. Not, like travel has kind of hit a decline, but it's ramping up quickly. And that's why these things need to be maintained, is there's considerable risk that can be avoided when you actually have an automated process that is consistent. Yeah, and as we're getting in more use cases, right? I think of it as everywhere. Now, for me, like I really look at road systems, rail systems, sewer systems. Yeah, as Jeff mentioned, remote environments, especially power lines and energy equipment, right? Like a fault somewhere in a transformer because of corrosion can cause a wide variety of issues that is difficult to fix. Vehicle parts, right? Like whenever you examine a tire now, or brake pads, or anything like in the engine, visual predictive maintenance could actually come in, right? We're taking unstructured data, we're taking imagery and saying, okay, like let's examine this with an expert eye. We're doing this expert translation where you have potentially a mechanic look at it. That'd be a really cool use case. Is you could just take your smartphone and be like, hey, like VPMX this engine, like figure out what's wrong. Is there anything wrong with it? This is a Honda Accord of this model, like what's wrong with it? That would be a really cool use case. And finally, buildings, right? Building security. The incident in Miami was very unfortunate. We're a condo collapse, but there was a lot of cracks within that building that could have been avoided. And insurance companies really care about this. They're the ones ultimately who have to pay something, and they really want to push this sort of, hey, like let's be proactive about these maintenance issues. Yeah, so we're going to talk about a real world use case with aircraft. And again, the challenges that I had to address when I was talking to the fleet team there. Corrosion, leaks, cracks, peeling, high unit cost. Those cracks and corrosion can down a jet. We've heard the story before. It's manual. It's a human process. And we wanted to replace that with a highly accurate, consistent model workflow that they can quickly iterate on, but also verify and improve. So over time, they can get better and better. And I'm going to give you a quick look at some of these examples. So hopefully you can see that. And this is a jet. This is a very important jet to the fleet. And we built a model in that same day, in under an hour, with very few images of just bounding boxes. So this was annotated images that we annotated in the Clarify platform, right? We created these bounding boxes. And with that training set, we then fed a custom detector, right? It was very easy to build this detector, a few switches, we named it, and we gave it all the concept classes, and we just hit the train button. And immediately we were able to see, okay, this is getting all the fastener parts in areas of corrosion very efficiently. But here's something I really want to emphasize. As Jeff mentioned, it's really about, making an eye, but can we get beyond human level performance? What we're doing now is actually passing this area, this cropped area, to a deeper classifier. And what we eventually want to do is over time assess that risk and see how the corrosion evolves, right? This very, very simple process is something they don't do right now. They can't do it, right? You can't ask someone to store into memory how corrosion is evolving on fastener number 112 on the left side panel, right? Like it's incredibly difficult for a human to do this. In addition, do it for all 80 jets in the depot. And then finally, like how risky is it? We built a model to do this, and we're doing that today. Another one I do want to show you, as I mentioned, the importance of paint and lightning strikes, right? Like I just showed you something that detects fasteners. We can also detect paint peeling and rivet rash, right? Very important things like on the surface of a jet where we can actually analyze this. Now that is that 99% problem that I'm talking about. And it's as simple as taking that and actually turning it into this, right? Is monitoring corrosion risk, like low corrosion, medium corrosion, high corrosion. Like what's the amount of fasteners, let's say, on this panel that has high corrosion? That alone is very important. Is it a vertical stabilizer? Is it a horizontal stabilizer? Is it the left side panel, right side panel? Is it near the cockpit? Those things alone help. This is how the actual fleet team assist the pilot to actually make this fleet ready. Is what's the corrosion risk, right? Like of the parts, like is it really heavy on one side versus the other side? What does that mean? Before they didn't have any of this, so it was more just let's eyeball this and let's just fly. And now this is a complete departure from okay, like how do we actually assess the safety of this jet? And how do we actually say okay, this is fleet ready, and this is something that will be fleet ready for a long time, right? That's the predictive quality that we're talking about. But it all started from taking very unstructured data and making it structured, right? Like if we did none of that, that's the hard part. If we did none of that, that's just eyeballs. And imagine human maintainers making something like this. There'd be mistakes everywhere. You'd get a lot of false positive behavior where, again, that's reduced fleet time, or worse, a false negative, right? A false negative situation where someone's like, this is fleet ready, let's go fly it. And it's not.
Could we explore just a little bit on that structured versus unstructured point you were making? What do we really mean by that?
Yeah, no, totally. So structured data, right, like in the ML world and the database world, think of like rows and columns, like time series data of like floating point values, right? Like temperature, right? Like you could see temperature, right? Like it's a structured data form. Even though it's a floating point kind of value, right? Like it's considered structured. Unstructured is like an image, right, of pixel information. What is that image of, right? This is where deep learning comes in, computer vision. This is where object detection comes in. From our side is what is that image in the first place, right? Classification, detection. You have to build specialized software essentially that we call deep neural networks to do this. Now the architectures are constantly evolving, but the way practitioners approach that is let's try different architectures and then just pick the best one, or let's use an ensemble, or let's stitch them together. You really need that underlying engine to quickly do that, right? Like I could use one of the new architectures like a vision transformer to do the same type of detection that I'm doing with that model, but I need to be able to verify it, right? Traditionally, I would have to restart everything. I would have to just do it all from scratch. And suddenly that 99% problem is has its own 99% problem of just operational deployment and things I don't want to worry about. I just want to experiment. So that's where I'm actually using a platform like Clarifai to actually do that. Structured data, consequently, you could see as like since it's structured, it's sometimes easier to maintain and search and index, but bigger problems actually lie in unstructured data. And with aircraft, I can give an example again of analyzing sensory data, right? Like they're getting from the actual avionics versus the hull. There were many times where they're analyzing the avionic data and saying, oh, this jet is fine. Whereas you look around the jet and it's not, right? Like you're missing a huge component if you're not looking at it visually. Sometimes it's greater than the avionics data because that can be manipulated, it can be modified. A lot of times it can be noisy, right? There's no sense of it. But I don't want to completely say, okay, structured data is quote unquote bad, right? Structured data alongside the unstructured data intelligence is very good. What's even better, right, is I've been talking about is things where we've taken structured data and actually transposed it as like in a visual environment. Think of like sonar, think of spectrograms, where someone came to us and said, this is structured data, right? Well, as long as you have like a screen feedback, right, and you can turn it into like, let's say a graph, let's try it. Let's try an actual vision model that we've used for traditional imagery and see how it does. And that's the experience we've been getting for things like IR thermography, where someone has to stare at a screen and it looks like a spectrogram, right? But they're seeing heat dissipation to monitor for potential cracks that could down a jet, right? So it's not that structured data can't be transformed into an unstructured form and then reanalyzed by a vision model. So that's what I mean by that. Images, videos, audio, even like natural language, think of that as unstructured, right? Like you can derive a lot of meaning from it. It's very dimensional, high dimensional. And then structured data, think of like rows and columns, right? Like a time series of temperature readings or something like that.
So if I could throw this out as just a bit of a higher level way that I like to conceptualize this, you could go out with your cell phone and take a bunch of pictures of a jet and then put those pictures in a spreadsheet, and they would just take up one column. Each column would just be the image you took.
Exactly, yeah.
Adding structure, what we're saying is that you then can create new columns, put a name at the top, say Rusty Bolt, say wing, say leaky fastener, say really anything. You can, as long as it's visually identifiable, you can add new columns to that spreadsheet and use an ML model to fill it out for you. So instead of having to just have the one column where the only way to make sense of that image would be to click on it and physically look at it, you can just automate. And this is where the customer really needs to feel free to use their imagination. I mean, we're not the experts in jets. Those columns can be anything you ever wanted to know that's visually identifiable. And it's incredibly easy as he's showing you there. So the fastener streak, that's just one column that then you can automatically populate with very little training data because of all this 99% work that Clarifai spends its days taking care of for you. And it is very complicated. But as the customer, it's going to be this fairly straightforward project, and then that can then be put into charts and graphs or use.
And furthermore, a lot of these customers are they have edge requirements, right, or on-prem requirements. There's nothing stopping you from training something in the platform. There's nothing stopping you from training it on-prem too. Clarifai can be deployed on-prem to train, but we're seeing individuals train on the cloud and actually deploy on-prem or even at the edge, right? So with fleet readiness, that really becomes important at the edge, just having intelligence right there. For security reasons as well, right? Like that's very important for IP protection. So we can deploy this at the edge, right? And there's actually a good question around underwater capabilities that someone had. So for underwater, the way we approach kind of detection or classification right now, like we're depending a lot on sonar, right? Like there's a lot of occlusion that can happen underwater. But there's nothing stopping you from trying, right? Like we haven't had a use case yet where someone is underwater and taking pictures of, like, let's say a shipwreck or something like that, but there's nothing stopping you from trying that, or even like a submarine, right? It's if we can ingest that data, that imagery, and there is an expert that can say, okay, like this is what this means, you can create a computer vision model around that. Furthermore, at Clarify, I mean, we're really kind of abstracting this. We want to say, okay, we really want to see normal versus abnormal. Like, is there a model we can create that's just general anomaly detection? Can you give us images that say, okay, this is a normal, let's say, computer chip, this is an abnormal computer chip. The model will find the delta and say, okay, this is why, right? Like, here's the map of like where it's abnormal, right? And that'd be very valuable for a lot of things, right? Like, especially jets, but like very uncanny data, as I like to see it, is with uncanny data, you're looking for those anomalies.
Yes, indeed. And we're closing in on 10 minutes, just to maybe mention this to Praneet and anybody else. And feel free, if you look at the bottom of your screen, there's that hand icon. Go ahead and raise your hand if you have any specific questions, if you're feeling brave and want to have a conversation with us. We are encouraging it. We want people to take advantage of this time to deepen their knowledge of their specific use case, certainly.
I think someone has a question here.
Yes, indeed.
Yeah, so I think we can unmute. I don't know if they have to unmute, actually. Oh, there you go.
There we go. Hey, Robert.
Hey, how you doing?
Good. Well.
So I work in consumer packaged goods manufacturing for a major beverage company.
Mm-hmm.
And our production lines have, dozens and dozens of components that are prone to any number of failure, be it from corrosion, lack of lubrication, just general wear, general use wear. But a lot of it moves at, say, 900 cans a minute, right?
Yeah.
Right. So is there, I guess, would you need to partner this software with high speed imaging?
Yeah,
or
and that
use say data from the PLCs, right, that are just on the line, or some combination thereof.
I would actually recommend both, right? I would actually, from a POC standpoint, you can actually use individuals to take imagery to kickstart a training sort of exercise. As I'm kind of showing here is just a simple example sort of diagram. But the way we did it with the jets is like there wasn't like a high speed imaging or a drone even of taking imagery. Like you can actually use, like, let's say a really small set of imagery that kind of describe the anomalies in question, and even start with like one piece of equipment. Eventually, yeah, if you do, depending on the criticality of the equipment, it might make sense to partner with a camera provider. Now, you mentioned high speed. I mean, Clarify's worked on models that run at 60 to 120 frames a second. So it really depends on like the criticality of the equipment, right? Is if you need to really monitor something precision, right? Like the higher the better. But usually, running a model with a video stream at like 10 FPS to notice something as static as like corrosion is like more than enough. Even like taking static imagery once in a while to see evolution is more than enough. But I think the really critical component here would be training the models and doing that knowledge transfer of like, what's the type of equipment? How critical is it? What does it do? And then what are the corroded parts that you want to examine? So did you have like an example? Like, is it like the treadmill or is it like the actual, can't even think like the modern marvels, but like,
No, so it depends on where you are on the line, right? So if you're anywhere near the filler or where the actual soda is made, right? All that sugar and everything else is just naturally corrosive over time. I mean, even with really good cleaning, it just gets in the crevices.
yeah.
Right? and then then there's always water present, right? So I mean, even when you use, good stainless steel, good aluminum, over time, the presence of all that just wears on parts, right?
Yeah.
I was at a production site one day where a gear on a conveyor just wore out, right? I mean,
Yeah.
and what really happened was, the maintenance guys just missed it, right?
Yeah.
I mean, it's something that if there was some autonomous model just looking at it to say, hey, you know what, these teeth are now 5 or 7% out of spec.
Mm-hmm.
Someone needs to come look at this, right?
Yeah.
I mean, like right now we use a similar model just on the finished product, right? Like, so the bottles go past the high-speed camera, and if the cap is tilted, it gets kicked out. If there's not enough product, it gets kicked out, right?
Oh, interesting. Okay.
So we use it on product, but not so much on the actual equipment to keep the equipment up and running.
Interesting. Okay. Yeah, I mean, there's many use cases around using what typically people use for surveillance, right? Like to just see the building security, like they're actually repurposing for VPMX, as we call it, because just it's constantly monitoring anyways. Could you reorient that use case to do it for gears or sort of compliance for cleaning, right? Like you mentioned, like the lack of cleaning would cause corrosion over time. That's a very interesting use case that we do approach, like just like you're talking about the finished product. We do have a customer that is examining the final bottle, but not anything that was does all the mechanics of that production. So we could definitely apply that. My recommendation would be, I mean, there's so many different parts, right? With the jet example I was showing, like focus on one, because there's many things you could look at in a jet. We chose to focus on one just to kind of refine the model. A really bad thing that usually happens with models is like model drift, right? Like there's too many confounding clauses and confusion. We want to, our take is really build one model for one use case, like a gear corroding. So not only does a model know that this is a gear, it's learned the sort of like anomalous patterns of a gear, right? And then can identify it or even alert it, right? Like based on, certain patterns. That's how I would look at it.
And I would just kind of want to double down on what Praneet said about the frames per second, saying that 10 frames per second is usually plenty. This is a common misunderstanding as people start looking at this kind of technology. We're in a fast-moving process, you do probably want a fast shutter speed so that you can capture something that is whirring around at a high velocity. But in terms of sampling the image, you don't actually need 180 samples per second. That unless you're somehow tracking motion or trying to track something physically over time specifically, that higher frame rate doesn't help you. And rather it's a clarity of the image.
Yeah. And just to kind of circle back to justifying all this, like you really have to look at the pain points the downstream. Like Rob, I would ask you, like, what did that result in, right? Like, because you can actually calculate per bottle, like the price of the bottle, and a broken conveyor belt, like if it's 900 bottles a minute, like how much lost production that is. That's how you justify these things around, like certainly the engineers and the field engineers and the field teams are like, we need this because this automates a lot of my headache. But justifying to people, executives, higher ups, like, okay, we need this because this is what this did, right? Like this cost this much money. That's how AI is justified. How anything is justified, from a procurement standpoint, but like how AI is particularly justified, especially with this, because it can be very R&D focused, but it has very big applicability.
And hey, everybody, we're running out of time in today's session. Praneet, how would we recommend people following up with us if they do have more specific questions about their business, about their use case?
I mean, we got emails. We could provide the emails. I think we've got everyone's contact correct, so we can reach out. We can, feel free to email us. I love talking about this stuff, so I'd want to know more and more about each of these use cases. But as we keep going along, we're building models for every use case. And one day, you know, we'll have the one general model that just detects anomalies. So that's kind of the hope here.
All right, everyone. Well, hey, thank you so very much for joining us. We're going to make this webinar available. The recording will be available online within the next day or two. And again, please reach out to us directly if you have any questions. And I believe the best way, we do have your emails already, but I believe we would just want you to go through you can just go to the Clarify website, and at the top of the page, you would see request a demo, and that's a way to get in touch with our sales team. All right. Thanks so much, everyone.
Thank you.
See you next time.